Hi everyone, and welcome to the first video in our prototyping design series, where we'll explore how to use different tools and techniques to make your prototypes. In this video, we'll be going over the basics of 3D modeling using a CAD software called OnShape. So what we'll be making today will be something that's probably familiar to almost everyone, a Lego block. But what we're going to do is we're going to design it so that we'll be able to customize it however we want. So CAD stands for computer-aided design, or just using computers to help the design process. But usually these days, when we think of CAD, we think of a 3D solid modeling program, such as OnShape, which is what we'll be using today, or another common one is SolidWorks, or it can also refer to drafting programs like AutoCAD. Since this is a prototyping series, we also need to go over what prototyping is. So prototyping is the process of taking an idea to a working product. And it's one part of the design thinking process, which is the process that you go through when you're making almost anything. The first step is empathize. This is where you figure out where your product is going to be applied. The next step is define, where you actually figure out what exactly your product is going to solve. And after that is what most people think is the first step, which is ideate. And that's where you actually start thinking of ideas, thinking of what you want your product to actually do and how it's going to do it. The fourth step, prototype, is what we're doing right now. So it's taking those solutions that you've ideated and trying to make it real. You try to get it to a point where you can move on to the next step, which is test. When you're testing your prototype to see if it actually solves the problem that you've defined. And if it does, whether or not it does it in a satisfying way. So the goal of prototyping is to really quickly develop your idea and test it just to see if it works. So the design thinking process is not a linear process. You're going to have to go back and forth through each of these steps multiple times before you come to your final product. The whole point is to refine your prototypes so that each prototype solves your problem a little better than before until it finally behaves like you imagine it should. So when you're ideating, you might want to sketch your ideas. And when you're sketching, it's useful to sketch the different projections of your idea. So as you can see here with the Lego block, you can see the top, a cutaway side, and the bottom view. And these three views all together give us all the necessary detail that we need to model the Lego block. Now once we get into modeling, we have to think about how we're actually going to create all those details that we saw before. So a good way to think about this is like sculpting. You go from a very basic shape and then you add even more relatively basic features and more until you get your final result. Another important concept is design intent. So since we're working with software, the computer does not know what you're trying to do. It can't make sense of anything. It's just a number cruncher. So when you're making your design, you need to structure your designs in a way that when somebody else looks at your drawing, they can make sense of it too. So a good rule of thumb is to imagine if you came back to this drawing after a year or two, would you still be able to make sense of it? If the answer is yes, then you've provided a good amount of design intent. So here you can see an example of bad design intent. So you can see everything is defined using exact measurements and very arbitrarily. Like you can't make any sense of it at all. If you wanted to make edits to this and still keep the same Lego shape, it would be impossible because you'd have to change a million measurements at once. This one is a lot better. You can see that there's only about 4 actual measurements defined. Everything else is defined using geometric relationships, which are much easier to understand. If you wanted to make changes to this, you can easily just change one number and the geometric relationships will make everything else fall into place. So when we think about CAD, usually we think of it as the final step where you have your design, you have your prototypes, and now you need to formalize that design so you can send it off for people to manufacture. But it can also be a very useful early prototyping tool. Because of how easily you can alter measurements and change the shape of things, you can go into your CAD software and really test out all the different parameters of your design before making it into a physical prototype. So with that, let's get drawing. So OnShape is a browser-based CAD program, which is nice because you don't have to download and install any big programs, and you can work from any computer. When we get started, the first thing you see is a very standard file navigation window. Like if you've used Google Drive, you know how this works. So we can create a document, we'll call it Lego, and it's going to create a little workspace for you. The important things are the left-hand bar here, which shows all of the different parts and features that you're going to make, and the top, which is where all of your toolbars are. So what we're going to do first is we're going to define a single stud on the Lego block. And a stud is just one of the circle things on the Lego. So what I'm going to use is the center point circle. And what that's going to require is a center point, which I'm going to snap to this origin point here. I'm just going to click and drag and click again. All right. Now you want to pay attention to your cursor, because if you see this cross, it means that you're still in some kind of tool. So you see, if I try to click anywhere else, I'm going to start creating circles all over the place. So I'm going to undo that. And you see now it's a normal cursor. So that means, I can actually select things and move it around. So I can still move this around, and it's in a blue outline, which means that it's not yet fully defined. So in order to fully define it, we use the dimension tool. So what I'm going to do is I'm going to define it as 4.8 millimeters. So you see that automatically rescaled it, but that's okay because we can just zoom in. And now I'm going to define a square around it. So in order to do that, I need to select the center point rectangle. Again, snapping to the middle. And I can be really approximate because I can, more specifically define the dimensions later. But I want to make sure before I define the size, I want to make sure that I define it as a square. So if I select two of these edges and go down to this menu here, this is the constraints menu, which is where all of the geometric relationships are. I'll select the equals constraint. And that'll make it so that whatever I do, it's going to be a square. And then I can define a single edge as 8 millimeters. And there we go. And that's our first sketch. So you can rename the sketch if you want, but I'm not going to do that here. Alright, so now I can go to a different view. So we can start seeing how to manipulate it in 3D. So what I'm going to do is use the Extrude tool. So this is probably the most common one you'll use. Extrude. And it'll want me to select a couple of faces. So I'll just select this whole thing. And I want to make sure to select the little circle too, because I don't want that in this, this particular extrusion. So what I'm making right now is the square base. And in this case, I want it to go downwards, like so. And the depth, I want a depth of 9.6. All these measurements you can find online of official Lego block measurements. All right, and that's good. So now I'm going to create another one. But you see here, after using that extrusion, the sketch has turned invisible, but we want to reuse it. So we're going to turn it back on using the eyeball button and click on the circle to create our stud. So this one's going to be 1.6. So you can already see how this can be customizable, because whenever you want, you can go into either the sketch or the extrude, and you can start messing with the sizes. So if I want this to be 12, it'll automatically update. But I want it to be 8, so I'm going to keep it like that. Alright, now we have a single stud. Let's make it look more like a Lego block. So what we're going to do is use the linear pattern tool to just create a couple copies. So the entities to pattern, you want to make sure, just select the whole part. And we need to pick a direction. So what we can do is we'll just pick a couple of flat edges. So I want it to repeat in this direction. And you see it'll start to repeat in that direction. But I don't want it to be that far away. I want it to be touching each other. So I'm going to say that distance will be 8. I want that instance count to be 4 because I want to do the classic 2x4 Lego block. But I also want to switch the directions just because I think that looks nicer. So another thing, so you see how each of these blocks are sort of separated right now. We don't want that. We want this all to be a single piece. So we want to make sure to change this menu up here to add. So as you can see here, it's changed this all into one solid object. But we also want to repeat it in the other direction to get that classic 2x4 shape. So this is where the second direction comes into play. So we have to choose a direction, which I'll choose this edge here. Change the instance count to 2 so we can see what's going on. And change the distance to 8, just like the other. Alright, and there's that. So once you feel happy with that, click the check. And look at that. Our Lego block is pretty much almost done. But of course, there's still the important part of the actual holes that allow it to fit together. So we're going to make another sketch. Go to the sketch plane. I'm going to press N to view normal. That's one of the keyboard shortcuts. And what I'm going to do is use this offset tool. So the offset tool basically allows you to click a bunch of edges and have it extend out by a certain distance, which makes a lot more sense for this instance in terms of design intent than let's say drawing a new rectangle in the middle. So here we go. If I press enter, it'll have you sort of set the size of it. So I'm going to say 1.6 because I know that's what that is. And that's it. I press escape to escape the tool. I can move the dimension to a place where I can see it a little bit better. And now we want to create the 3 little circles that we know are there. So basically what these are supposed to be for are to create more surface area for the studs to grab. And yeah, so I've created these 3 circles, and now I want to use the geometric constraints to set them all equal to each other. Okay, so if you ever get confused about, what's been constrained to what you can do is, you can either test it, or you can use the show constraint button, and that'll show you what's constrained to what. All right, so now what we want to do is we know these circles need to be touching these studs, but we don't know where they are until, All right, now once we have this offset rectangle here, that sketch is finished. And what we can do is we can cut into it. So we'll use the Extrude tool, and this time we'll be using the Remove option. And make sure to select the right sketch. And we're going to be using the different end types here. So instead of blind, which is just an arbitrary number that you set, I'm going to use the up to face option. And that's going to make it so that I can choose a geometric relationship for this extrusion. So I want it to go up to this face, but I want it to offset. In terms of design intent, this makes a little bit more sense because I know sort of how thick I want the ceiling to be. So I'm going to say I want it to be 1.6 millimeters because that's the thickness of all of the walls and ceilings of this Lego block. And that's it. All right. So we're almost done. The only thing that's left is these little tubes that go in the center of this hole. And what those tubes do is they basically provide a little bit more grip so that the studs have more to hold on to. So what we're going to do is we're going to be defining these tubes without using any actual dimensions. We're going to do it all using geometric constraints. So we do that by making a sketch. So you see I'm selecting this inside plane here. And I want to make sure to switch the views here. I want to switch it to shaded with hidden edges. So as you can see, now I can see all these studs and all of the detail that's hidden from me, and actually interact with them too. So with that, I can start creating so I'm going to draw one circle, and I'm going to use the tangent constraint right here and make it tangent to these 3 circles. So you see I only need to define it to 3 circles because of math. But yeah, that's all that's needed. Now for the inner diameter, I know that the inner diameter is big enough to fit a single stud. So I can just use an equals constraint for that. So I'll do it to this one, and that's it. All right, and now I can do an extrude, select the correct one. Now I'm going to use the up to face again, so that because I know it's got to be flush with the rest of the Lego brick. So now that's done, and I can do another repeat. So this time we're repeating one of these features instead of repeating a sketch. Wait, no. Yeah, so we'll be using another linear pattern. So this time we want to, instead of doing a part pattern, we want to do a feature pattern. And we want to do a feature pattern of this extrude. And the direction, again, I'll just choose this line here, reverse the direction, and say 8 millimeters again, because that's the correct distance. And I want 3 of them to match this. All right, so that's finished, and I'm going to set the view back to shaded, hide the sketch, and that's our Lego block. It's pretty much finished. We're not quite done here yet though. So if we try to actually fit copies of this Lego block together, if we actually 3D printed this and try to put them together, they won't fit. And the reason for that is these circles and all these spaces are defined exactly to be the right size. And manufacturing is never that precise and never that accurate. So what we need to do is we actually need to include some clearance, basically to allow for that variation of dimension. And the easiest way to do that in OnShape is with the thicken tool. No. And the easiest way to do that is with the move face tool. So move face, as the name suggests, moves faces. So what I can do is I'm going to set a distance of 0.05 because that's the amount of clearance I want to give to each of these sides. And I can just start selecting each of these faces. So I'm going to select all these faces and the inner diameters as well. Now as you can see, if you zoom in on it, you see this new face is actually moved inward. And we don't want that. We want to create more space, not less. So we'll just have to switch the direction. Now that's good. And then we can go and select these top studs as well. So as you can see, now everything is ever so slightly smaller. All right. There's one other side that we need to add clearance for, and that's the outside edges. Because when these blocks are stacked next to each other, they've also got to leave a little bit of room for any variation during manufacturing. So we're going to make this 0.1, just give them a little bit more space, and switch that direction. So you can see, slightly smaller, so that's good. And now we have our complete Lego block. So now if you want to, you can export this as an STL format and send it to a 3D printer, and you can mass manufacture Lego blocks. Well, not that fast because 3D printers are slow, but here we go. If you have any questions, feel free to contact the Student Startup Center through our social media or through email. And that's it. Thank you all for watching. Bye.